One video is not enough for this. You may need to record 2-3 videos. But I will start with the very basic property of matrices. And in a very detailed manner, I will explain it. So the first property is related to condition on multiplication. See, I will explain conditions as well as symbolic proofs like transpose, inverse, adjoint, where symbols will be used and we need to prove it. Okay. So the first point is condition for multiplication of matrices. Two matrices. Two matrices. Number two is AB equal to BA. Number three, can we write A into B plus C as A into B plus A into C? Fourth, can we write A into BC as associative property like AB into C? So these three properties are very important as far multiplication is concerned. Now the fifth one, what is symmetric? Before that, let me tell you what is transpose of a matrix. What is transpose? What is transpose of a matrix? And number six, what is symmetric? And it's two symmetric. Matrix. And the last one, which I will discuss in this video, is to prove AB transpose is equal to B transpose A transpose. So let me start with the first one, the condition. See, matrix multiplication is a little bit different from that of determinant matrix multiplication. So in matrix, what we'll do, we'll have to follow a condition. So what kind of condition? Condition is number of if number of columns of matrix A is equal to number of columns, sorry, number of rows is equal to number of rows of matrix B, then only is on the first. Then only we can multiply two matrices. Let me show you by the example. Suppose A is 2 into 3 matrix. So 2 rows and 3 columns like A1, A2, A3, B1, B2, B3. And now let B is 3 into 4 matrix. So 3 rows and 4 columns like L1, M1, N1, P1, L2, M2, N2, P2, L3, M3, N3, P3. Okay, this is 2 into 3, this is 3 into 4. So we can multiply it because 3 columns and 3 rows. How to multiply? You will have to take this particular row and first this column. So AB will be summation A1 L1. summation A1 L1 means A1 L1 plus A2 L2 plus A3 L3. Corresponding elements multiplication. Now keep this row as it is. Now move to the second column of B. So this is A1 M1. Then again move to the third column. This is summation A1 N1. And then the last one, this is summation A1 P1. Once it is done, then move to the second row. Then again B1 L1, B1 M1, B1 N1, B1 P1. In this way, this is 2 rows and 4 columns. 2 rows and 4 columns. Okay, so this is the condition for multiplication matrices. Number of columns of matrix A is equal to number of rows of matrix B. And the resulting matrix will have 2 into 4 row and column. Okay. Now come to the second part. Is AB equal to BA? No. No. Not in general. Exception may occur. Why? Why it is so? Now in the second part, is AB equal to BA? Not possible always. Not possible mostly you can say. Why? See, the condition of multiplication is like A's number of column is equal to B's number of rows. So if A is say 2 into 3 and B is 3 into 4, then when you multiply B into A, so 3 into 4 and 2 into 3, these two are mismatched, not satisfying condition. So in general, it is not possible. Condition of multiplication, right? Yeah, it is possible in some of the cases, like you can say A into I is equal to I into A, where I is identity matrix. Suppose this is 3 into 3, this is also 3 into 3. So here we can see this, but these are exceptions. These are exceptions. And mostly it will happen in square matrix only. Now, can we write the distributive property? Yeah, this you can understand, like if we add B and C, na, B and C will be added if its order, row and number of rows and number of columns for both B and C will be same. So if there is a situation where we can multiply A with B plus C, then we can multiply with A and B and A with C. Okay. So the required condition for multiplication is fulfilled here because the order of B and C and B plus C all are same. So this is okay. This is okay. This we have explained. Now come to the fourth one. Can we have the associative property? So the fourth one is A into BC is equal to AB into C. So this is, true. Why it is true? Like, let me check it. Suppose B is 3 into 2 and C is 2 into 4. So what is BC? B into C is, BC is 3 into 4. Now if A is 2 into 3 and BC is 3 into 4, then we can multiply it, right? Now you can see A and B are matching because ultimately the number of rows of BC will come from number of rows of B. So you can keep A and B together. So here this is possible. Also A into B is possible. And again A into B will have the order like If A is 2 into 3 and B is 3 into 2, so this is 2 into 2. Now, if you multiply with C2 into 4, so it will come AB into C as 2 into 4. Okay. And here also it is coming 2 into 4. 2 rows and 4 columns. So in this way, we can examine like this is associative also. Okay. So this is a very important property. Distributive associative, we can take it as granted. But commutative, AB equal to BA is not in general possible. It is not possible generally. Now, what about transpose of a matrix? Now, number 5, let A is equal to, suppose A1, A2, A3, B1, B2, B3, C1, C2, C3. Then A transpose is simply, for A transpose, convert rows into columns. So, A transpose will be equal to A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay. Now the next one, what is symmetric matrix? Symmetric matrix means for symmetric matrix A equal to A transpose. Or you can say if A is equal to A transpose, then the matrix is called symmetric. And for skew symmetric, A transpose equal to minus A. Now, can we have some example? Yes. For this, you can take A, B, C, A, B, C, write a row, same column. Then D, E, D, E, F. So if you take its transpose, it will come same. Suppose the first row gets converted into first column, then B, D, E, and C, E, F. Now, example of this, you can easily take A is equal to. Here you should try the diagonal elements as 0, 0, 0. So let me write. In fact, the diagonal element has elements rest 0, I think. Let me see. 0, 0. A, B, C. Let me check. 0, 0. I mean 0, 0, 0. Let me check. B, C and minus B minus C. Okay. This way it is okay. D and minus D. So when I take the transpose, so 0, B, C minus B, 0, D minus C minus D, 0. Okay. So this is minus A. So you can get this type of situation. Just a minute. This is 0. Okay. So you keep diagonal elements 0, 0, 0, then BC, then minus BC, then D minus D. So you will get this. So you keep remember this. Now there was the last property to prove AB transpose is equal to B transpose A transpose. So this you can easily understand, like this is also related to row column and the condition of multiplication. Like if A is 2, 2 into 3 and B is 3 into 4, then AB is 3, 3 will be removed 2 into 4. So AB transpose is 4 into 2. So this will only be possible if we multiply B transpose, which is 4 into 3, and A transpose, which is 3 into 2. So these two will be removed and BT, AT will be again 4 into 2. So AT into BT will not be possible. You will have to reverse it. 4 into 2 and 4 into 2 will be matched. So go through this video and you will get the all valuable informations, some very important properties of matrices. And in my next video, I will move further. Okay. So please revise it. Thank you.